learned a little bit more about charge and current and voltage, with voltage and current, how they relate to work, we want to try to solve this example problem. And so again, we're given equations for the charge and the voltage, and we're going to use those to determine the current, the power, and then determine the maximum power. So we want to determine expressions for those. So here's the setup of our problem. We've given our charge in coulombs expression, our voltage in volts expression. We're trying to determine I of t. And so as we just learned, if you watched the previous video, we know that I of t is equal to dq dt. So it's the derivative of q with respect to time. And so we have our function q. The way we would take the derivative of that is we can leave this coefficient out front of 150. The derivative of sine of an angle, again, if we use our handy sheet, sine omega t is we bring omega out front, and it's cosine of that same omega times t. So it would be 250 times the cosine of 250 pi t. Sorry, this would be 250 pi times cosine of 250 pi t. And then I can simplify that and get that I of t, this 50 would cancel out here. I end up with 5 pi cosine of 250 pi t. So there we get I of t is 5 pi cosine 250 pi t. P of t, again, from previous work, remember these expressions. Remember, it is the derivative of work with respect to time, and then we could break down work into derivative of work with respect to charge, which is voltage, and times the derivative of charge with respect to time, which is current. So now we have two expressions that we know, and we can plug in the expressions that we know and try to solve for power. So again, I can have the expressions for velocity and the expression for current, which I just solved above. I'm going to multiply those two things together. And so I get 500 pi times the sine of 250 pi t times the cosine of 250 pi t. And that's an interesting enough expression. But I can simplify a little bit more if I use a double angle identity. So wouldn't necessarily know it's a double angle identity, except if I go back to my sheet and find that sine of 2t is 2 sine x cosine x. So if I use that double angle identity, my x is 250 pi. I'm going to get double that for the sine in here, so it ends up being 500 pi. But I also have to divide out front by 2, so I end up with 250 pi in there. So just coincidentally, those things switch place. But it is half of that and doubled inside gives me 250 pi times sine of 500 pi t. So I have a single expression for power. Once I've got my expression for the power, to find the maximum power is actually pretty simple. So because this is a sine wave, I know it's going to fluctuate depending on time by this factor. But we know that the amplitude tells us how much it fluctuates. So at the peak, the P max, it's going to be amplitude. So it's simply equal to the amplitude, which is 250 pi. And I need to make sure to get the units on that. The units for power, of course, from the top are watts. And of course, the minimum would be negative 250 pi. So yeah, so that solves our electric circuits example.